Okay, number 26. So we're still finding the tangent and the normal. Y equals, nope, I lied. Not y equals.
Y does not.
X squared cosine squared y minus sine y equals 0. The point is 0 pi. So we got to take the derivative first. Remember, we're doing implicit differentiation. So we have a product rule plus a chain rule with implicit. So what is the derivative of x squared cosine squared y?
X squared times negative sine squared y times y prime.
You're missing a piece. So remember that cosine squared y is the same as cosine of y squared. So you just took the derivative of the inside without doing the outside part. So we would need 2 cosine y times the sine of y, minus the sine, minus sine.
Negative sign.
Thank you.
I mean,
Of y times y prime. And then plus the derivative of the first part, so 2x, and then cosine squared y. Gotta get rid of this. Minus, what's the derivative of sine of y?
Cosine
I'm gonna call it y
times
y prime cosine.
Cosine y prime.
Can I put that y prime in front of the cosine?
It doesn't matter.
Okay. No, it's just hanging out over there.
So I get negative 2 x squared cosine y sine y prime plus 2x cosine squared y minus cosine y prime equals 0. So I just basically rewrote the stuff in the beginning. Terms with a y prime need to stay. I'm going to leave them, but also factor out the y prime all at the same time, because remember I need to get y prime by itself. So y prime times negative 2x squared cosine y sine y minus cosine y equals negative 2x cosine squared y. And then we need to divide. So y prime equals negative 2x cosine squared y over negative 2x squared cosine y sine y minus cosine y. Now, anyone notice anything that I can do
You can cancel a negative.
to make life easier? You cannot, well, okay, you can cancel the negative, but we're going to get there in a second. What else can I do? What does every piece have in it? Can't do that.
It has a cosine.
Has a cosine. So let's take out on the bottom a negative cosine, and on the top we'll cancel the negative and a cosine. So negative 2x cosine squared y over negative cosine y times 2x squared sine y minus 1. Nope, plus 1. So then negatives cancel, cosine cancels, so I just have a cosine y on the top. Now I can plug in 0 and pi. So pi for y, 0 for x.
What were they solving for again?
the slope.
So that's all you have to plug it in.
Now, had I realized that we had 0 and pi, I would not have just reduced all of this. Because what's going to happen on top when I plug in 0 for x?
0.
What happens when I plug in 0 on the bottom?
0.
Well,
Well, we have a plus 1.
plus 1. So, it would just be 0. Now, I'm going to show plugging it in just so that you can see it.
That's me printing from. So do you mind if I share that document? I want to see if I print that
Oh,
document.
yeah, I don't care.
Okay.
I'm just showing this so that y'all can see that this stuff is going to, like, what we would have been doing if this hadn't gone to 0. So this is the slope of the tangent. So I need the equation of my tangent line. I'm going to rewrite the point down here just so that I don't forget what I'm dealing with. So how would I write my equation for my tangent line?
Y minus pi equals
0.
0.
X minus 0.
Yeah, you would not have to actually write this right hand side part. You could just write 0, but just for your visual if you go back. So y equals pi. So if I need the normal, what's the slope of the normal? Did it print normally when you did it?
Mm-hmm.
I don't know what's happening.
I will look into it.
Thank you. I don't know. It's
I'll such a mess.
Doesn't scare me. I used to exclusively work on Macs, like not like work on them, but you know what I mean. Like I
Yeah.
had all the products, and then I went broke. And
This literally just started happening this morning. Like, I printed a test for them the other day, and it was totally fine. So I don't know. I just thought something was wrong with the toner, which is why I was calling.
No, I mean, cause we get the copier emails us like when it's low on toner and stuff like that.
Yeah.
And it's
Well, Jacob said this
insane.
was supposed to be able to do like 20,000 pages. So I was like,
Yes.
if we're getting low, something is wrong.
It's a workhorse, and that's where it's like I don't understand why because and you know what? Let me try one more thing. Because I was like equal.
It's a little confusing. It's a little confusing having that there. Sometimes you're like, oh, number pad. Oh, that doesn't type like that. All right, what's the slope of the normal? So what's the equation of the line?
X equals, let's say 0.
Do you agree or disagree?
Either that or pi. I can't choose.
Did you fix it?
I'm gonna say x equals 0. Yeah, I'm gonna
Is
say
it just a
pi.
setting?
I went in and I re-highlighted it and
Don't put that at
black.
the
Or actually,
wrong.
I did it over there
Don't put it at
too, and then I refreshed your page here, and it seems to be just fine now.
Okay.
So I don't know if it needed to be. I don't know if it was because it was Windows. I don't know if it was because like I went through and I was like, we're just gonna make sure because it was interesting when I highlighted everything. I don't know if that threw it off, like because it was a
Oh,
hyperlink.
maybe.
But it like because I re-highlighted it and like there was not a color, so I just selected
So weird.
black.
Yeah, I just have to put
and-
it online. I just wanted to make sure for like somebody
Yeah.
else, if I send it to them, it's not
Yeah.
going to be weird. So
Oh yeah, no. So but there you go. So here you can
Okay.
have these copies back.
Thank you.
You're welcome.
Appreciate
You're welcome,
you.
Pauline. Anything for you, darling. Anytime. You guys can have her back now. Thank you.
They may not want me back. All right, it would be x equals 0
Oh, yeah,
because it has to be through the x value.
Yeah, I think that's how I reasoned it in my head.
So all that work for the equations of your lines to be y equals pi and x equals 0.
It's alright.
Oh well.
Hey, we just wanted the derivative practice. That's where we're at.
Yeah.
I knew it was going to be that. I just was going to make y'all work the problem to see.
Yeah.
All right, use implicit differentiation to find dy dx and d2y dx.
Ew.
So we're finding the first and the second derivative, which means that we may have a y double prime. Virginia's not sure how she feels about that.
I don't even
I know how I feel about that.
I probably will not be saying many answers for this one.
X to the 2/3 plus y to the 2/3 equals 1. All right, y'all should have no problem with the derivative of x. So what is that?
2/3 x minus, or to the negative 2/3.
-1.
Negative
1/3.
I don't-
Subtracting 1.
Yeah, see.
Minus 3/3.
Close enough.
All right, plus we have this derivative here. So it's 2/3 y to the negative 1/3 times y prime equals 0.
Where did the 0 come from?
You take the derivative of 1.
Oh, yeah.
Sorry, that was a little aggressive.
Yeah.
My apologies.
It was unnecessary.
Josh getting a little crazy in here.
I know. Well,
I just need to get the SAS overload out.
All right, so we are going to subtract, divide. So I'm going to try to do this all in one step. Y prime equals negative 2/3 x to the negative 1/3 over 2/3 y to the negative 1/3.
Hold up.
All right, so
2/3 x 1/3 over 2/3 y to the 1/3. Okay.
okay, 2/3 are canceling. These have negative exponents, so they're flipping. Okay, so I'm going to end up with y prime equals negative y to the 1/3 over x to the 1/3. Okay, or you could rewrite this as negative parentheses y over x raised to the 1/3. Either of those things would be sufficient. But then,
But wait, there's more,
yes, so much more.
unfortunately.
Now we have to take the derivative again.
Nice. Let me consult my notes.
So, I would probably backtrack to this way to take the derivative just to make your life easier instead of trying to do a chain rule and a quotient rule,
Ew.
which is what this format would give us. So, derivative of y prime is going to be y double prime equals derivative of the top. Let's just include the negative on the top.
Wait,
Just
so the derivative of y is y prime, right?
the derivative of y
Mhm.
is y prime. The derivative of y squared is 2y prime.
Okay. So if it's just a y by itself, then you just add a prime.
Yes, because it's just like if you take the derivative of x, it's 1. So it's 1 times the derivative of y, technically.
Okay.
All right, so what would the derivative of this top piece be?
Negative 1/3 y. Oh my god. Would it be to the negative 2/3?
Yep.
Okay.
Good job.
So the negative 2/3 times y prime. And then
So I'm going to just make this a positive then.
Y to the 1/3 times 1/3 x to the -2/3 divided by x to the 1/3 squared.
Math makes me impress myself with how small I can write.
Okay, so I've got, I'm trying to think of how I want to rewrite this because, or at what point I want to start rewriting stuff.
Should we just like
Let's
take
just
up
get
as much space as we need?
everything in alphabetical order at the moment. Let's just start that. So let's do -1/3 x to the 1/3 y to the -2/3 y prime plus 1/3 x to the -2/3 y to the 1/3 over x to the 2/3. Now, have a little bit of a problem. I have a y prime in there.
Little meaty.
So, what I'm going to do is I'm going to take this that y prime is equal to, I may actually use this one, and I'm going to plug that in for y prime.
That's brilliant.
Okay? So, I'm going to take this value, bloop, plug it in there. So, I'm going to have -1/3 x to the 1/3 times, I actually am going to go ahead and rewrite this y on the bottom.
Okay.
But
Go
like
for it.
when I say that, I mean 1 over y to the 2/3 like on top. Like it's not actually going all the way to the bottom because it can't yet.
Oh, well. I guess still go for it.
Times, hold on, I need to rewrite this x to the 1/3 situation here. I'm struggling. Okay.
I'm struggling too.
Times, I'm rewriting y prime as, okay, look, this is negative. I just want us to track here. This is negative. I'm going to make it positive.
I'm still gonna write it as negative.
That's fine. I'm just trying to not have to write another step. So then y to the 1/3 over x to the 1/3.
I like the x to the 1/3 though.
Me too. Plus 1/3 debating if I want to rewrite that yet.
Would that be 1 over 3x to the 2/3?
I'm not going to rewrite it yet. What?
What?
Yes, but I'm not going to rewrite it that way yet.
Okay.
I'm going to wait.
I wasn't gonna rewrite it that way either.
Okay, I'm not going to, well, the bottom's small, just, okay. All right, x to the 1/3 up here cancels with this because it's all being multiplied. I have one in the top, one in the bottom. Now, I probably could have just left the y to the -2/3 on top, truthfully, because what can I do with if I have y to the -2/3 times y to the 1/3?
You can subtract.
Y
like the
to the
exponent.
negative.
Yep, so I'm going to actually backtrack on what I said, and I'm going to rewrite this back as what it was. I didn't realize initially that things were going to cancel like they did. I thought the y was good. I thought the y needed to be on the bottom to cancel, but then I realized x was canceling. So, sometimes that happens. Okay, so up here, I would be left with 1/3. I'm going to factor out the 1/3 because it's in both pieces. And you could have done that earlier on. It just, it's all about how you want to do it. So 1/3 times y to the negative 1/3 plus x to the negative 2/3 y to the 1/3 over x to the 2/3 I'm gonna move this 1/3 to split it, so it's like this. Because then I don't even need the one on top anymore then. Because I can get rid of the parentheses. I'm gonna move this 3 over now. I'm trying to not have to rewrite the whole thing over and over again. Okay, so now I think personally I would split these up into 2 separate fractions with a common denominator. So I can move this to the bottom. So I would have 1 over 3 x to the 2/3 y to the 1/3 plus, I'm going to leave y to the 1/3 on top, over 3 x to the 2/3 times x to the 2/3. I'm moving this one to the bottom. Huh? Well, something's not right, I don't think, in the answer, so.
That's great.
Oh, wait, maybe? Hold on. Never mind, we are right. I know what's wrong. Okay, hold on. So we have 1 over 3x to the 2/3 y to the 1/3 maybe not. Nope, I still know what's wrong. Okay, we're good. We are Gucci. I know what's happening. Y to the 1/3 over 3x to the 4/3. I need a common denominator. That's why I thought my answer was weird. I was like, this is not the final answer. And it is not the final answer because I have not gotten a common denominator yet. What would I need to do to the left fraction to have a common denominator?
Get rid of the y to the 1/3
Okay, well, so this one needs to be multiplied by what? This one's also going to get multiplied by something.
You got this, Virginia.
Josh has no idea.
I'm gonna say you need to multiply.
Y to the 1/3 over x to the 2/3, maybe?
Okay.
No?
If I had
You just multiply them by each other.
1 over
Oh, that's
4 plus 1 over 6, and I need a common denominator, what would you tell me to do? Ignore everything over here for the moment.
Multiply it by, no, 12.
Oh. I was just doing.
I'd go for
What am I multiplying over here?
3 over 3,
Okay, 3 over 3. What am I multiplying over here?
2 over 2.
Okay. What do I need to multiply this one by to deal with the x to the 4/3? I understand this one doesn't have a y to the 1/3. You know what? Backtrack. Let's deal with this one first. What do I need to multiply this one by so that it looks like this one? Y to the 1/3.
Yay! Thank you for being
Okay,
smart, Virginia.
now,
X to the 2.
yes, x to the 2/3. God bless America.
Thank you for taking that one.
Josh is like, I had no idea.
I got you, Josh.
All right, so on top, as one fraction, I would get x to the 2/3 plus y to the 2/3. Nope. Yes, y to the 2/3. Over 3x to the 4/3, y to the 1/3. Boom. There's y double prime. Only took us 15 minutes, but we got it.
I think we'll have one like that on the test.
Possible.
It's like that one problem that I forgot what it was, probably because it was so scary.
The one with the really long.
Uh-huh.
Oh yeah. I remember
Probably quite close to my memory.
All right. Same type of problem.
Ew.
30. Y squared plus 2y equals 2x plus 1. What's the first derivative?
that. I'm writing it down.
Josh, you got this one.
2y prime plus, I'll call you 2y prime equals 2.
All right. Gotta get y prime by itself. Factor out a y prime. 2y plus 2 equals 2.
Can we factor out the 2 on that other side now?
Yes, I'm just gonna cancel the 2's because I know y'all know to factor it out. So I get 1 over y plus 1.
Yay.
So, first derivative. Boom. Y double prime equals, what's the derivative of the right side?
0 minus 1.
I must say y prime.
So 0, the derivative of the top is 0, minus the top, which is 1, times the derivative of the bottom, which would just be y prime. So I'm just not writing the 1 times that part. All over
My y prime.
y plus 1 squared so now
The y prime, the 1 plus, I mean 1 over y plus 1.
yep. So negative 1 over y plus 1 over y plus 1 squared. Would you agree that I could rewrite the top part as negative? I don't know what that was. Y plus 1 to the negative 1.
Yes.
Okay. If that's the case, what do I need to do?
Move it to the bottom.
Move it to the bottom. Happens to be the same thing as down here. So this would be negative 1 over y plus 1 cubed.
Now, see, I was thinking that it would be that. But I guess that'll just explain why it does that.
Yes.
So now
I could have also just said, well, I can multiply, or since this is a fraction, I can just do 1 over that and put that on the bottom and multiply.
Yeah.
But,
So now the brain understands it better.
yes, I'm trying to show you the why behind it.
Calculator?
It's on your book.
Oh.
Okay, good, because I just found mine.
Oh.
I thought she was about to borrow it. I was like, you probably want to keep it for math class. I mean, we don't really need it today, but.
Yeah.
All right, a few derivatives here. 32,
How much space do you think those will take? 'Cause that's all I have.
1,
left
2,
on this
3,
side
4,
of the paper.
5 lines.
Do I have enough width?
Oh, yeah.
So is this for like all of them, or just this one?
Both problems that we have left.
Okay.
Y equals x to the negative 3/5. What's the derivative?
Y equals negative.
Y prime.
Yeah.
Oh.
Yeah, but
It's,
yeah.
I mean, y prime equals negative 3/5 x to the negative.
Got this.
Wait, let me think about this.
Think faster.
Oh, negative 8/5.
There we go.
I was gonna say that, but then
What
I-
in the world is
I was trying to help her out while you weren't looking.
Try to keep me,
I was like,
phone a friend.
and then my eraser wasn't working.
That's what I was trying to do in my brain.
But your eraser wasn't
Yeah, I'm not working.
You can leave it here if you were so inclined and you wanted to. You could write this as negative 3 over 5x to the 8/5. Either way would be fine. They leave it as the negative, but if you rewrote it to not have the negative exponent, I wouldn't care. 40. Y equals 3 times 2x to the negative 1/2 plus 1 raised to the negative 1/3.
Oh, okay, so they are getting complicated. Ish.
These are basically like basic derivatives here. They're just making them more confusing. All right.
Negative, or y prime equals negative 1. So there's like a negative.
Yeah.
Negative 2x to the negative 1/2 plus 1 times negative.
No. Raised to the.
Oh, raised to the
I would have forgotten that
negative 4/3 times negative x to the negative 1. No, 3/2. It's the fractions that get me.
So then I would just multiply negative and negative here. So you would get x to the 2/3. Nope. Negative 3/2. Dyslexic upside down. Times 2x to the negative 1/2 plus 1 raised to the negative 4/3. And I would leave it there. All right. Any questions? Beautiful. Y'all might regret not asking for problems over the weekend. Because we have a quiz on Wednesday.
Are you able to see like how many times we've missed your classes? Because I'm like curious to see how many absences I've had. Or is that like something the office tells you?
I can look it up.
Uh-huh.
Or have them like look it up for me. But y'all are both fine.
Okay.
Because as long as I like